Some creations happen by accident, while others happen because of a deliberate vision to solve a pressing problem, fill a strategic gap, or give one side a decisive edge. Yet even with the boldest promises, not every design delivers on what it was meant to achieve. The disappointment of falling short can be just as intense as the excitement that surrounded its creation. And in military aviation, only a few aircraft capture this contrast more vividly than the Eurocopter Tiger. To some, it stands as an underrated triumph of European engineering, blending speed and agility into a formidable package. To others, it represents an overhyped experiment weighed down by political compromise, development delays, and lingering performance concerns. This sharp divide has fueled a debate that refuses to fade, because in warfare, the margin between life and death can be measured in seconds. Armies require machines that can strike hard, move fast, and endure the chaos of the battlefield. For Europe, that machine was the Eurocopter Tiger, a Franco-German creation conceived to rival the finest attack helicopters in the world. Since its first flight, the Tiger has drawn both praise and criticism in equal measure. Admirers see a tool with remarkable survivability and combat capability. Detractors argue it is a costly and complicated platform that never truly lived up to its promise. The truth may lie somewhere between these opposing views. So strap in, because we're about to take you from boardroom blueprints to combat deployments, through political wrangling and battlefield dust. By the time we touch down at the end of this story, you will have everything you need to choose your side in the ongoing debate over whether the Eurocopter Tiger is underrated or overhyped. The Eurocopter's Tiger begins in the quiet corridors of European defense planning rooms. It was the mid-1980s, and the Cold War was still very real. NATO forces faced the prospect of Soviet armor sweeping across the plains of Central Europe, and European militaries knew they could not rely indefinitely on American air power to halt it. France and West Germany decided to pool their resources and create a homegrown attack helicopter capable of meeting the threat head-on. It was a political move that showed that Europe could design and build its own combat masterpiece without serving merely as a junior partner in someone else's program. To make it happen, two major aerospace companies, Aerospatiale of France and Messerschmitt Bölkow Bohm of Germany, joined forces. Their eventual merger into Eurocopter would seal the collaboration and give the Tiger its multinational identity. The new helicopter had to be fast, agile, and survivable, capable of destroying tanks, delivering close air support, and performing reconnaissance. It had to operate equally well in European forests, dense urban environments, and extreme climates. Above all, it had to integrate the most advanced avionics, weapon systems, and armor protection available in Europe at the time. The Eurocopter Tiger was engineered to be a lethal combat platform, built from the ground up to balance speed, firepower, and protection. Its airframe is almost entirely composite, reducing weight, resisting corrosion, and lowering its radar signature. At its core, the Tiger is powered by two MTR-390 turboshaft engines developed by the French company Turbomeca and the German firm MTU Aero Engines. Together, they produced over 1,000 shaft horsepower each, enabling the helicopter to reach speeds of more than 290 km per hour and operate at altitudes above 13,000 feet. Its four-blade main rotor, made of carbon fiber reinforced plastic, is designed to absorb damage and keep turning even when struck by small arms fire. The cockpit, on the other hand, features multifunction displays, helmet-mounted sights, and a digital avionics suite that allows the crew to share targeting data instantly. Both the pilot and the gunner sit in a tandem arrangement with full flight controls, ensuring that either can fly the aircraft if needed. Its weapons loadout changes depending on the mission, but a typical Tiger can be equipped with a chin-mounted 30mm GIAT cannon, air-to-air missiles, anti-tank guided missiles such as the AGM-114 Hellfire or the PARS-3LR, and unguided rockets for close air support. This flexibility allowed it to switch roles without lengthy reconfiguration. These design choices place the Tiger among the most advanced helicopters of its generation, yet every technological leap comes with trade-offs. Weight distribution, maintenance demands, and intricate systems integration meant the Tiger was not always straightforward to deploy or maintain as its designers intended. That complexity would go on to determine how the Tiger performed when it left the controlled environment of the factory floor and entered the unpredictability of combat. It is in this arena, where metal meets dust and theory meets reality, that the true verdict of the Tiger began to form, and that is where our journey heads next. Before the Tiger could prove itself, it had to survive an unforgiving gauntlet of trials. The first prototype took to the skies in April 1991, a sleek silhouette that looked every bit the part of a modern attack helicopter. Yet flight tests revealed not only the Tiger's agility and speed, but also a host of technical issues that would slow its journey to operational status. The Franco-German program faced constant scrutiny. Delays mounted as engineers worked through vibration problems, software integration issues, and weapon systems calibration. Political debates over funding and work share between the two countries added further friction, with each side determined to see its industries benefit equally. The Tiger was no longer just a military project. By the early 2000s, production variants were ready to enter service. Germany opted for the Tiger UHT, a variant tailored for anti-tank warfare and air-to-air combat, armed with missiles and rockets but no fixed cannon. France chose the Tiger HAP, which included a 30mm GIAT cannon and a broader focus on close air support. Australia and Spain would later adopt their versions, each with unique adaptations for climate, mission profile, and national weapons compatibility. The Tiger's baptism of fire came in Afghanistan, where German, French, and Australian crews used it for reconnaissance, troop escort, and precision strikes. It would later see action in Mali against insurgent forces, flying in extreme heat and dust where reliability mattered as much as firepower. Pilots praised its handling, night vision systems, and weapons accuracy. Maintenance crews, however, faced long hours keeping the helicopter mission-ready in harsh conditions, a reality that fed into its reputation for being high maintenance. These early deployments showed that the Tiger could perform well in combat, but also that it was not invincible to the logistical and operational challenges that have undone many ambitious aircraft. In the realm of attack helicopters, reputation is built as much through comparison as through individual merit. For the Tiger, that meant constantly being measured against machines like American AH-64 Apache, the Russian Ka-52 Alligator, and the Italian A-129 Magusta. Each of these helicopters brought its strengths, proven combat record, and unique design philosophy, and each offered a mirror in which the Tiger's qualities and shortcomings were reflected. Where the Apache was celebrated for its durability and formidable weapon suite, the Tiger offered lighter weight, greater agility, and a smaller radar signature. In European forests and urban landscapes, that maneuverability became one of its defining traits, allowing it to hug terrain and approach targets with precision. Yet in terms of sheer armor protection and battlefield survivability under heavy fire, the Apache's record in places like Iraq and Afghanistan was difficult to ignore. Against the Russian Ka-52, the Tiger presented a different kind of contrast. The coaxial rotor system of the Alligator offered exceptional stability and lift, especially in hover. In contrast, the Tiger's conventional main rotor and tail rotor combination gave it smoother, high-speed handling. Both helicopters carried advanced targeting systems and anti-tank weapons. When placed along the smaller Italian A-129, the Tiger's size and payload capacity were clear advantages. It could carry more weapons, more fuel, and operate in more extreme climates. However, the A-129's lower operating cost and simpler maintenance requirements made it attractive to nations looking for compatibility without the same logistical demands. These comparisons, repeated in military assessments and defense press reports, ensured that the Tiger's image was never formed in isolation. If the Tiger's design was shaped in the planning rooms of Paris and Bonn, its reputation was shaped as much in the budget committees and parliamentary hearings of the nations that built it. From the outset, the program carried a price tag that drew scrutiny. Initial estimates in the late 1980s promised a modern attack helicopter at a competitive cost. Still, delays, evolving requirements, and the complexity of managing a joint Franco-German industrial effort pushed expenses far beyond the original projections. By the time production models began to reach operational units, the cost per helicopter had risen to levels that made even well-funded militaries take a second look. Australia's acquisition of the Tiger ARH variant became a case study in procurement challenges. With delays in delivery, integration issues with local systems, and concerns over parts availability, French and German forces also reported high maintenance hours per flight hour, a metric that defense ministries could not ignore. The politics of the program added another layer of complexity. Work-share agreements ensured that factories and subcontractors in both countries benefited, but they also meant that changes or upgrades had to navigate a web of approvals and industrial obligations. At times, the political will to preserve jobs and national involvement outweighed purely operational considerations, slowing decisions that might have streamlined the fleet. Critics seized on these issues as proof that the Tiger was an example of over-engineered European defense projects, technically impressive but weighted down by bureaucracy and cost. Supporters countered that it represented a leap in European aerospace capability. The Tiger's value as a combat platform could only be truly judged once it was placed in the unforgiving conditions of active operations. In Afghanistan, it provided escort for troop transport helicopters, scouted ahead of convoys, and struck targets in support of NATO ground forces. There, its maneuverability at low altitude allowed it to weave through valleys and avoid enemy observation, and its advanced night vision equipment gave it a clear advantage in after-dark missions. In Mali, French Tigers played a central role in counterinsurgency operations, flying in oppressive heat and dust where mechanical endurance was tested daily. They delivered precision strikes on fortified positions, supported rapid troop movements across vast desert expanses, and maintained a presence that deterred insurgent attacks on isolated outposts. These missions demonstrated not only its firepower, but also its ability to adapt to varied mission profiles within the same deployment. Australian Tigers saw combat in a different operational environment, providing armed reconnaissance in the Asia-Pacific region and supporting peacekeeping deployments. These missions reinforced its capability for surveillance and deterrence, although they also revealed that maintaining high readiness levels required a significant logistical footprint, especially in remote areas. Every operation leaves behind both achievements and lessons. Crews gained confidence in the Tiger's handling, targeting precision, and the ability to deliver a range of weapons accurately. At the same time, commanders recognized that long-term effectiveness relied heavily on consistent maintenance support, streamlined supply chains, and continued investment in upgrades. The result was a combat record that neither fits the mold of an undisputed success nor that of a failed project. Instead, it tells the story of a capable yet demanding machine whose performance was shaped as much by the environments it flew in as by the skill of the crews who operated it. By the mid-2010s, it was clear that the Tiger would need more than routine servicing to remain relevant in evolving battle space. The answer came in the form of comprehensive upgrade programs aimed at extending its service life and improving its operational flexibility. France began rolling out the HAD variant, a more powerful and better-armed evolution of its earlier HAP models. Germany pursued modernization for its UHT fleet, focusing on software upgrades, enhanced communications, and integration of new guided rockets to increase precision strike operations. Spain adopted for similar enhancements, while Australia's experience led it to push for solutions that reduced the heavy maintenance burden, which had limited availability in early years. Looking forward, Airbus has proposed the Tiger Mark III, a deep modernization package that aims to align the helicopter with next-generation combat systems. Planned improvements include advanced electro-optical sensors, upgraded defense aids, and even greater integration with unmanned systems for cooperative targeting. If fully adopted, these changes could keep the Tiger in frontline service well into the 2040s. The Eurocopter Tiger occupies a rare space in military aviation, one where perception often overshadows performance. It has never enjoyed the universal acclaim of the Apache, nor the instant recognition of the Russian Hind, yet it has carved out a distinct identity. Supporters point to its ability to conduct complex missions across radically different environments, from dense urban areas to open desert, and to do so with a degree of sophistication that reflects Europe's highest aerospace standards. They highlight its adaptability, modular design, and steady evolution through successive upgrades as proof that it remains a relative tool in modern warfare. Critics, however, see it as emblematic of the risks inherent to multinational defense projects. To them, the Tiger's capabilities are impressive, but come at a cost that limits its appeal to a narrow group of operators. They argue that its operational history, while respectable, has not yielded the kind of transformative battlefield impact that would justify its complexity. Perhaps the most telling aspect of the Tiger story is that it continues to inspire strong opinions decades after its inception. That alone suggests it is neither a forgotten footnote nor an unquestioned triumph. Instead, it is a study in contrasts, a platform that embodies both the promise and the pitfalls of modern defense innovation, Even the most carefully planned designs can deliver unexpected results when they face the realities of the battlefield. The Eurocopter Tiger has divided opinions for decades, a machine that inspires fierce loyalty from some and deep skepticism from others. It has flown in war zones, weathered political storms, and evolved in ways its designers could not have predicted. If you thrive on stories like this, Project Aerospace is your front row seat. Subscribe now, join the mission, and see the next breakthrough before it makes headlines.